Hi. We are in chapter 8. So this is our first official lesson of chapter 8. Yesterday we practiced, factoring a quadratic, and we found what the x-intercepts were, and we made a little rough draft sketch. Today we're actually going to get into graphing. We're going to use a table of values, and I pick really small numbers and we plug in these table of values. So I want to talk to you about this list on the board, which I guess I should put on the paper since you can't see it on the video. So, -1 squared. What would -1 squared be? -1 squared. What is that? -1 squared. Yeah, it's a positive 1. -1 times -1. It means that number multiplied by itself twice. Positive 1. How about like a -2 squared? What's that going to be? Positive 4. -2 times -2. Positive 4. What about a 0 squared? 0 times 0. 0. Yeah, easy. What about a 1 squared? Michelle and Gavin, you gonna... All right, 2 squared. 2 times 2? 4. Good. And I wrote, which we did last semester already, but all my other classes are now focusing on this, so you guys are ahead of the game. But knowing the perfect squares, and we took a pop quiz on that, I would say maybe September. So I'm hoping those didn't disappear from your brain. I'm hoping. All right. So let's do some definitions. I've got quadratic parent function. The quadratic parent function is going to be a standard U-shaped all other parabolas are based on this. All the other parabolas are based on this one. A quadratic function is ax squared plus bx plus c. And then the actual definition, the word parabola, is an upward U or it could be facing downward shaped graph. So I'm going to show you the easiest quadratic parabola that exists. It's just plain x squared. X squared would have like a 1 in front of it, but again, nobody writes a 1. So I could put y equals x squared or f of x, function notation, x squared. It means the same thing. I'm going to graph a parabola, and a parabola has an exponent of 2 on it. I picked these small numbers, -2, -1, 0, 1, and 2. And I'm going to teach you, in case you forgot, how to do a table of values and plug in for x squared. So, in The left column, I tell you what x is worth. X is worth -2. In the middle, I want you to plug it in. So I want you to put x squared, but it's going to be, instead of x, -2. -2 squared. Sorry. No.
Have you been taking medicine?
I didn't take any cough drops today. I should have. What is -2 squared? +4. So that means that my x comma y, my input, my x was -2, and my result, my output, is +4. Okay, plug in -1 for x squared. -1 squared. That means -1 times -1. +1. And my ordered pair would be -1, 1. 0 squared. Easy, yeah, 0. 0, 0. It's kind of up to you if you want to put parentheses around them in the table of values. Obviously, work ahead of me if you got it. 1 squared, 2 squared. So this parabola, let's graph it. Ordered pairs. -2, +4. Always start at 0, 0 when you graph a point. 2 to the left, and then 4 up. -2, 4. -1, 1. Left 1, up 1. 0, 0. 0, 0 is my vertex. 0, 0 vertex means where my graph turns, where the curve actually curves. And now I'm going to do the other side of the parabola. 1, 1. And then 2, 4. So these points now are going to be connected. I want you to make a smooth line. It's not a V-shaped. It's a U. And these two lines are going to go forever up in both directions with arrows at the end. So make a smooth curve connecting the points. Thank you. So what is the vertex? What was that ordered pair that I said the vertex was? Where is the curve of this parabola? 0, 0. Good. Now, does this open upward or downward? Upward. So, upward. Now, it has a lower bottom point. See how this bottom point, my parabola bottoms out right here? That means that it has a minimum, a low point. So this bottoms out right there. It has a low point. It's called a minimum. So this is going to be a minimum. I'll just underline the word minimum. Yes. Okay, I just graphed the parent function. All right, this is the basic parabola. I'm going to use like PF sometimes, parent function. This is the x squared. This is just a basic parabola. Parabola. It does. It takes like, you'd have to say it like a few times to get it. Parabola. 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 So now I'm going to be putting numbers in front today. Instead of just x squared, I might put like a 3x squared or a 2x squared. So I'm going to be changing the way that this parabola looks. And that's what's on the next page. So let's turn the page. If you have another color, like a blue pen or a black pen and a pencil or a red or something, you can use that. So now I'm going to show you how the parabolas look different. So how does the value of the leading coefficient A affect the graph? A changes it and makes it skinnier or fatter. So for example, here's my normal x squared. I'm going to do it in red. This is the one we just graphed on the front. If I have a parabola that's skinnier, that's going to have a whole number in front of it. Like for example, this one is a 2x squared. This skinny one here, when a parabola gets fatter, that's because there's a fraction in front of it or a number less than 0, like 0.5 x squared or 1/2 x squared. I'm going to do that in purple. So what I did on the board over here is I wrote out what happens. If I have a 2, a 3, or a 4 in front of my x squared, like if the A value is greater than 1, it's going to be a stretch. It's going to get skinnier, more narrow. That's a 2, a 3, a 4, a 5, a 6, a 7, whatever, a whole number. If the number in front of the x squared is small, like a fraction, less than 1, A is less than 1, like a 1/3 or a 1/2, that's going to be a compression, which means it gets a fraction, gets fatter. And I wrote that on those next two lines. A stretch or a skinny is my blue graph. That's like 2x squared, 3x squared. If A is a whole number, A is greater than 1, the parabola is stretched. It's skinnier. So remember, we're talking about this right here. A y equals ax squared. We're talking about the a, or f of x equals ax squared. This a has the power to change, make it skinnier or fatter. My purple graph above had a fraction, like 1/2, 1/3, whatever, 1/4. If a is a fraction, the parabola is compressed. And it gets fatter, wider, fatter, wider, expanded more. So this is going to stay on the board. This 2, 3, and 4 greater than 1, skinnier. Fraction, 1/2, 1/3. A fraction makes the parabola fatter, wider. All right. Before we go on to 2b, I need you guys to practice this math over here. I want to make sure you can do it. So, order of operations says I need to do the exponent first. So that means that I need to do -1 squared first. It is a positive 1. And then I multiply by the 4. So the 4 comes at the end. 4 times 1. Yep, so my final answer of 4 times the quantity -1 squared is positive 4. Second one, I still do the exponent first. -2 squared. Do that first. 4. And then worry about the 3. Yes. Do the last one by yourself. Go ahead. What'd you get? Yep, you were right. So, I'm now doing x squared, but I'm multiplying every answer times 2. So on the left-hand side over here, I have my parent function. Parent function, y equals x squared. I'm going to rewrite what I did on the front page. On the front page, I didn't do a -3, but that's okay. -3 squared would be 9. And then 4. 1, 0, 1, 4, 9. I'm just squaring the numbers. This is my parent function, basic normal parabola that all the other parabolas are drawn off of. And then here, I put a 2 in. So first, let's graph my parent function. On the left in pencil here, what I did in pencil. I obviously can't do -3, 9. I just don't have the space. But I can do -2, 4. 2 to the left, 4 up. This is the same graph we did earlier. -1, +1. 0, 0. 1, 1. 2, 4. Again, this is my parent function. A smooth graph goes through it. This is where I need to go slow because I need to make sure that you're doing the exponent first and then multiplying by 2. 2 times -2 squared. I replace x with a -2. So, do the exponent first. -2 squared. 4. 2 times 4. Good job. -2, 8. Because x was -2, and so it's x, y. Now plug in -1. 2 times -1 squared. Do the exponent first. -1 squared. 2 times 1. -1 times -1 is 1. Good. -1, 2. You can put it in parentheses or you cannot put it in parentheses. It's up to you. Plug in 0. 2 times 0 squared. Plug in 1. 2 times 1 squared. Go for it. Two times 0. Zero comma 0. 1. 2 times 1 squared is 2. So you'll notice that this parabola, every parabola, has a left side and a right side. And they have to match each other, positive and negative. 2 times 2 squared. So in red, I'm going to graph my new stretched by 2 because there is a 2 in front of it. It's skinnier. Go ahead and plot the order pairs, please. Negative 2 comma 8. You can go off the graph. It's fine. Negative 1 comma 2. Zero comma 0. Michelle, please focus. 1 comma 2. 2 comma 8. Over 2 up 8. And then when you connect it, you'll see it is skinnier. It is more narrow. That's called a stretch by 2. So on your homework, every question, I want the parent function, the pencil, and then the new one. Okay. All right. We have one more to do. It is not a 2, a 3, or a 4. It's a fraction. This is going to be compressed. And it's going to be fatter by 1/3. So my parent function, negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. What? Am I going too fast?
No.
No. So this is 1/3. Notice how I plugged in a 3 because 3 and 1/3 will work well together. I have a negative 3 squared times 1/3. This means 1/3 times 9, which is like a 9/1.
Is that 3?
A 1/3 times a 9 is going to be 9/3, which is 3. But maybe you need to go slow because it's hard to do it in your brain, so go slow. Plug in negative 3. Plug in negative 1. All these values of x that I gave you, you're going to plug into the table of values. All right, negative 3 comma 1/3 times -1 squared. 1/3 times +1. Be careful. It's hard with the negatives and positives. 1/3. -1, 1/3. You have to write small, huh? 1/3 times 0 squared. 1/3 times 0 is 0. That's going to be my vertex. Say that again? You always want to plug in 0 as one of your choices because 0 is so easy to work with. So plugging in is smart. 1/3 times 1 squared. 1/3 times 1. And now 3 again. 1/3 times +3 squared. 1/3 times 9. So we need to graph PF, parent function, and my 1/3 x squared. On both the same graph. And this is what you're doing for each problem for homework as well. So, at your own pace, graph both of them. It's better if you do it in a different color. If you have two colors of writing utensil, you know. I'm going to graph the parent function first. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. So that's my parent function in pencil. My new fatter fraction compressed graph is -3, 3. -1. Ooh, 1/3 up. Okay. 1 to the left and 1/3 up. 1 to the left is a whole box. But only 1/3 up is going to be just not even halfway. A little, you'll make a dot in the middle of the box. Oh, a little under. Don't do it right in the middle. 0, 0. 1 to the right, up 1/3. 3 to the right, up 3. So 1/3 x squared is fatter than x squared. The last 3 questions on the bottom are just, we're going to look at the equation. We're not graphing it. We're going to look at the equation and tell, is it going to get skinnier, fatter? You know, skinnier means stretched. SS, skinny stretch. Fatter, compressed fraction, FF, compressed fraction, fat. What's a 4 do? Stretch it. 4 stretches the graph. 4 stretches the graph. 4x squared is skinnier than x squared. What does 0.8 do? That's less than 1, by the way. Compress less than 1. Yep. 0.8 compresses. Compress. 0.8x squared is fatter than x squared. One half x squared. Compressed. Good job. Because it's less than 1. It's a fraction. 1/2 x squared is fatter than x squared. So, your day 1 homework is 1, 3, 5, and 7. Day 2 tomorrow is going to be 2, 4, 6, and 8.
You're not going to be here tomorrow?
No, I am. I'm just putting this down so that you guys will write it, and that way you won't forget tomorrow's either. No.
Jesus. -2 and 2. Water.